Welcome to Quick Science. I'm Rob Brown, and today we're going to explore how ships float. If you want to follow along with today's demonstration, you'll need a large container or bowl filled with water, an orange, a piece of aluminum foil, and some paper clips or small weights. Have you ever wondered how a really big metal ship floats on water? An aircraft carrier can weigh more than 100,000 tons. Why doesn't it sink? Let's find out. But first, as always, let's put on our safety glasses. Now, the first thing we're going to do, let's take a small piece of aluminum foil and we're going to make a boat out of it. It doesn't have to be a fancy boat. All I'm going to do is kind of fold up the edges here, the sides here. Make a kind of vaguely boat-shaped object, just right like that. Now, let's go ahead and gently place the boat on the surface of the water and see what happens. Hey, our boat floats. Now let's load some cargo on our boat. Ships are full of stuff like equipment, people, and cargo. This is adding more weight to our boat. Let's see what happens though. Well, I put all those paper clips in there and it still floats. This is adding more weight to our boat, of course. If you want to do this for added fun at home, it might be interesting to see how much weight different shapes and sizes of boats can hold before they sink. But I'll leave that up to you to try at home. Now we're going to take our aluminum foil boat and we're going to do a little something. We know it floats. Now I'm going to smush it up. Just like that. Now let's see if it'll float. Nope. Doesn't look like it. So we know it floated before, so why doesn't it float now? Well, it's because of buoyancy. Buoyancy is the upward force of a liquid on an object. Water, like the water in our container here, is pressing up on the bottom of our boat, and if the upward force of the water is greater than the downward pull of gravity acting on the boat floats. When we crushed our boat, the upward buoyant force of the water didn't have the large surface area of the bottom of the boat to push up against. The weight was concentrated into a smaller area instead of distributed across a wider surface of water, so it sank. But that's only part of the story. If you pick up an orange, it feels pretty heavy. If I were to put this orange into our water, do you think it would sink or float? Let's find out. Wow, it floats. Now, we know the orange floats. I'm going to take that orange out. Now, just to save time here, I've actually already peeled an orange, or you can peel the orange you use for the first part of the demonstration. Now, let's go ahead and put the peeled orange in the water and see if it sinks or floats. Well, it sank. Why did the peeled orange sink while the bigger and heavier orange with its peel float? If you guessed the answer is in the peel, you're right. The peel, even though it's tough to protect the insides of the orange, is also spongy and filled with air in little pores. This makes the peel less dense than the center part of the orange. In other words, the peel acts like a life preserver on the orange. And this is why a 100,000-ton aircraft carrier can float. The buoyant force of the water pushes up on the bottom of the ship, which covers a huge area and spreads the weight of the ship and all the stuff inside of it out over the water. And the ship is full of rooms and spaces filled with air, just like the peel of an orange. This lowers the ship's density so it floats. That's it for today's episode of Quick Science. Until next time, stay safe.